Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 2 from section 6-4 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to graph transformations of logarithmic functions, or to understand what transformations happen. So let's talk about transformations first. All right, you guys have heard me. If you follow me, you guys have heard me talk about transformations quite a few times. Transformations for logarithms are the exact same thing. So you see an A, an H, and a K. So your A is a vertical change, right? Because it's outside of the grouping symbol, which in this case is the logarithm. All right. So if you have a negative A value, you're going to have a vertical reflection. If the actual number for A is bigger than 1, you're going to have a vertical stretch. And if the number for A is between 0 and 1, you're going to have a vertical compression. Now H and K, those are being added and subtracted. So that means that these are both going to be translations. All right. Now the difference between these translations is whether they are horizontal and vertical, and then the plus and the minus. So H is inside the grouping symbol, so it's a horizontal translation. And K is outside the grouping symbol, so it's vertical. Now the K feels like as you would imagine. Okay, when it says plus K, it goes up, and when it says minus K, it goes down. But because the H has a minus inside the equation, that means that we're going to have it opposite. So if I see an X minus H, I feel like it should go to the left because that's where the negative numbers are, but really it goes right. And when I see X plus H, I feel like it should go to the right because that's where the positive numbers are, but it actually goes left, and that's because of that minus there in the formula. So let's go ahead and take a look at the examples. So it says to graph the function, so that's what I did here, was I graphed it. I also graphed the parent function. And it says how do the asymptote and x-intercept compare to those of the parent function? All right, so in here I have an x plus 3. So that is a translation to the left by 3. And so you could kind of see if I draw in my asymptotes. Here's the one for my new function. And the asymptote for my parent function is at x equals 0. So you could see that it moved the asymptote left by 3, which kind of makes sense, right? If you're moving a function to the left by 3, its asymptote kind of has to go with it, right? And it also changed that x-intercept. So it also moved the x-intercept and the asymptote left by 3, okay? So whenever you shift to the left or the right, it's going to move your x-intercept and your asymptote, okay? So now in the triad, it just says to describe how the graph is going to compare. So I'm just going to describe the transformations, okay? So in this case, we have the natural log of x plus 4. So this plus 4 is actually outside of the logarithm, okay? The only time you count it as inside the logarithm is when there's parentheses around it. So this is actually a k value, so this is going to translate up by 4. So now let's think about the asymptote and the x-intercept. So when we shift it up, it's definitely going to move the x-intercept. Okay, so the x-intercept, it's going to move to the left when it goes up, right? Now the asymptote, shifting this up and down, the asymptote's a vertical line. So there's going to be no change to the asymptote. Okay, so now let's check out B. So part B here has a number times the natural log of x. Okay, so that's going to be a vertical stretch because that number is bigger than 1. So if I'm stretching, that means it's going to look like that or something. Okay, my asymptote is going to change. Okay, so well, actually my asymptote won't change, right? It's also not going to change the x-intercept, because when we stretch something, what we're doing is we are stretching it away from the axis. And so when I'm stretching away from the axis, it's not going to change the point that's directly on the axis. Alrighty, so there we have it, y'all. That is some transformations of functions with logarithms. Until next time.